dear students, welcome to Easy BTech, your guide for BTech and beyond. We are going to discuss Signals and Systems subject, and today's topic is Jtransform, problems on Jtransform, and we can also discuss properties of ROC. A very important session. All of you subscribe, share the channel. Let's start our session. So we are going to see some problems, then we discuss properties of ROC. So this is the session. So now the problem is Jtransform of e power j omega naught n u of n. What is the Jtransform of e power j omega naught n u of n? So this already we have seen. We know that Jtransform of a power n u of n. This we know already. So for this, what is the answer is z by z minus a, and ROC of this is magnitude of z is greater than magnitude of a, or magnitude of z is greater than a. So now by this, here a is equals, by comparing the given problem, here a is equal to what? E power j omega naught, and magnitude of a, that is magnitude of e power j omega naught, will be e power j omega naught magnitude cos omega naught plus j sin omega naught. Its magnitude is under root of cos square plus sin square, which will be 1. So this is about magnitude of a. Now the Jtransform, x of z is equal to z by z minus a. So z by z minus e power j omega naught. This is the simple answer, and ROC is mod z, or magnitude of z is greater than 1. Similarly, another problem, Jtransform of e power minus j omega naught n u of n. What is the Jtransform of e power minus j omega naught n u of n? In the same way, above problem, so its answer will be x of z is equal to z by z minus a. So here a is e power minus j omega naught. That's all. And what about ROC here? ROC is magnitude of z is greater than 1. So after knowing j omega naught n e of n, j e power minus j omega naught n e of n, we can do sine cos Jtransforms. So now next problem is Jtransform of sine omega naught n u of n. Sine omega naught n u of n. So how to perform this Jtransform sine omega naught n u of n? How to do? Sine function we can write in exponentials. Sine omega naught n u of n. So how to write sine in terms of exponential? Sine can be e power j theta, means e power j omega naught n minus e power minus j omega naught n by 2j. U of n is as usual. So u of n. Now we can separate this term. So Jtransform of e power j omega naught n minus e power j omega naught n, 1 by 2j we can write outside, 1 by 2j we can write outside, into u of n, right? Just I am writing separately, e power j omega naught n u of n plus, not plus, minus, Jtransform of e power minus j omega naught n u of n. So already we know this Jtransforms. So the first one, z by z minus a, that is e power j omega naught, and here ROC is magnitude of z is greater than 1. And the second one, so z by z minus a, z by z minus e power minus j omega naught, and here also ROC is mod z or magnitude of z is greater than 1. So here we have two ROCs. So final ROC is equal to common of these two, intersection of these two. So mod z greater than 1, here also mod z greater than 1. So final ROC will become, the final ROC is magnitude of z is greater than 1. Intersection of both is the final. Right? Now we are going to simplify this answer. Just I am doing LCM and simplification, nothing else. So the denominator z minus e power j omega naught into z minus, we have 1 by 2j also there, so take that 1 by 2j. Here z minus e power minus j omega naught 1 by 2j. So LCM z into, we can take z also common, right? In the numerator z is common. Now here z minus e to the power minus j omega naught minus, right or not, here minus z minus plus e power j omega naught. Okay, right? Just we are doing LCM, nothing else. So here plus z minus z cancel, and z by 2j. So here we have e power j omega naught minus e power minus j omega naught, and multiply this denominator z into z square, and z into e power minus j omega naught, e power minus j omega naught. Just I am doing simplification, and again minus z e power j omega naught, and e power j omega naught e power minus j omega naught will become 1. Right? Now still we can do simplification. Here 1 by 2j I can include here, that is z into e power j omega naught minus e power minus j omega naught by 2j. It will become sine omega naught or sine theta. So z into sine by the denominator z square. Here we can take minus z common, right or not? Minus z is common, and e power j omega naught plus e power minus j omega naught. So we can multiply, and by 2 it will become cos omega naught. So 2 cos omega naught. Therefore here 2z cos omega naught plus 1. This is the Z transform of sine omega naught n. Sine omega naught n. U of n. Right? And ROC, what about ROC here? Magnitude of Z is greater than 1. So similarly we can do for cos also. For cos omega naught n U of n. So Z transform of cos omega naught n U of n. What is the Z transform of cos omega naught n U of n? This cos function we can write in terms of exponential. So e power j omega naught plus e to the power minus j omega naught by 2. So into U of n as usual. Now we can write separately Z transform of 1 by 2 we can take out. We can write outside. Z transform of e power j omega naught n U of n plus Z transform of e to the power minus j omega naught n U of n. So already we know these are like a power n. So already we know Z transform and ROC. So that I am writing now 1 by 2. So for the first one, z by z minus a. So z by z minus e to the power j omega naught plus z by z minus a, z by z minus e to the power minus j omega naught. And ROC for the mod magnitude of z is greater than 1. Here also ROC magnitude of z is greater than 1. So final ROC is becoming mod z greater than 1, or magnitude of z is greater than 1. And by doing LCM we can do simplification. So z we can take common from the numerator. Here z minus e power minus j omega naught plus z minus e to the power j omega naught divided by the denominator is z minus e power j omega naught into z minus e to the power minus j omega naught, right? Now simplification of this z by 2, here z and z, 2z, right? And minus we can take common, and e power j omega naught plus e power minus j omega naught, it will become 2 cos omega naught, 2 cos omega naught divided by, so this multiplication already we know, z square minus 2z cos omega naught plus 1. So in the numerator and denominator 2 is get cancelled. So z into 1 minus cos omega naught, sorry, z minus cos omega naught, z into z minus cos omega naught divided by z square minus 2z cos omega naught plus 1. So this is the z transform of cos omega naught n q of n, right? And one more problem we can do, z transform of a power n u of minus n minus 1, a power n u of minus n minus 1. So this is the left sided signal. This signal is a left sided signal because of e power u of minus n minus 1, left sided sequence or signal. For this, what is the Z transform? We discuss now. So as we know, Z transform formula, Z transform of x of n is equal to x of z is equal to summation n is minus infinite plus infinite, summation n is minus infinite plus infinite x of n z power minus n. So the given signal x of n we can substitute summation n is minus infinite plus infinite a power n u of minus n minus 1 z power minus n. So here it is a left sided unit step sequence. Left sided u of minus n minus 1 is left sided unit step sequence, unit step signal. So this u of minus n minus 1 is 1 for left sided, means n is less than or equal to minus 1, right or not? From minus 1 to minus infinite, it is 1. So as per that u of minus n minus 1, our limits are minus 1, minus infinite, a power n, and this value is 1. So no need to write 1, z power minus n. So this total I am writing as n is equal to minus 1 minus infinite a z inverse power n, something power n I am writing. As we discussed, whenever we are doing Z transform formula, C power n format or series. So now here negative values of n I am making as positive values, like a z inverse power minus n, right or not? Here power plus n, negative limits, here positive limits, power minus n, both are same. Just I am sending that minus inside. Summation n is 1 to infinite a inverse z whole power n. So here we have summation from 1 to infinite. We need summation from 0 to infinity. So for n is equal to 0, we get a inverse z power 0, which is equal to 1. So n is equal to 0, we get 1, that 1 added and subtracted. Now combinedly, the next step I can write as summation n is equal to 0 to infinity, 0 to infinity A inverse z power n, and minus 1 is as usual. Now write, this is like c power n. So 1 by 1 minus c, 1 by 1 minus A inverse z, and minus 1 is as usual. And what about ROC here? ROC is A inverse z is less than 1. A inverse z is less than 1. Right? Now we are doing simplification of this, nothing else. Okay. So this will become, here A inverse z we can write as a z by A. So A by A minus z minus 1. A inverse z is z by A. LCM A. So that A will come into numerator. A by A minus z minus 1. Again we can do simplification. LCM is A minus z. So here A minus A plus z. So the result is A get cancelled. Z by A minus z. Z by A minus z, which we can write as minus z by z minus A. Minus z by z minus A. So this is the Z transform of A power n U of minus n minus 1. And what about ROC? Simplify ROC here. Z by A is less than 1. Right? Z by A is less than 1. Now Z is less than A. By this can tell Z is less than A. And if you plot ROC, we take real axis and imaginary axis. So take the circle of radius A. The circle radius is A. So now what is ROC here? Magnitude of Z is less than A, means inside the circle. Inside the circle of radius A. So this is inside the circle. This is real part, and here it is imaginary part. So what this problem is saying that if you take the left-sided signal of infinite duration or not, it is up to infinity minus infinity. Left-sided sequence, infinite duration. The ROC is inside the circle. How is the ROC? Inside the circle. That I am writing. ROC is inside the circle. So this is also a point properties of ROC. Okay. Now I am going to write properties of ROC properties. Very, very important in Jtransform. Okay, this is Jtransform. We have properties of ROC in Laplace transform also. Now I am telling about Jtransform. Okay, the first one, ROC of, the first property is ROC of Jtransform consists of a ring or circle in the Z plane. First point. So we have ring in the Z plane, center about origin. This ring center is origin. So centered about origin. This is the first thing. So we have a ring in Z plane, center, origin. Next, second one. The ROC of, or ROC does not contain any pole. Does not contain any poles. See, in any problem, still we have seen some problems. I am writing magnitude of Z is greater than A, not equal, not contain. That is the meaning. Next, third property is if x of n is finite duration, signal, finite duration signal. Then ROC is entire. Then ROC is entire jet plane except z is equal to 0 and or z is equal to infinity, and or z is equal to infinity. And fourth point, finite duration signal z is equal to 0, entire jet plane except z is equal to 0 and or z is infinite. And the fourth property, if x of n is infinite duration right sided signal, is completely right side and infinite duration, that is x of n, infinite duration right sided sequence or signal, right sided sequence. Then ROC is, how is the ROC? Then ROC is outside, ROC is outside the unit circle, whose radius is largest pole, whose radius is largest pole, outside the circle whose radius is largest pole, for infinite duration right sided sequence. Okay, next, fifth point, opposite to fourth point, means left sided and infinite duration. If x of n is infinite duration left sided sequence, this is a left sided signal, left sided sequence. Then ROC is, how is the ROC? ROC is outside here. Now here inside the unit circle, and whose radius is smallest pole, previously largest pole, now the radius is smallest pole. Now sixth point, two-sided signal. If x of n is two-sided signal, ROC is two-sided, sorry, if x of n is two-sided signal, then ROC is intersection or common, intersection of largest and smallest pole radius, largest and smallest poles or pole radius. So whenever you have two-sided signal, then the ROC is a common of two, largest pole, smallest pole, ROC, intersection or common. Next, another important point, stability. Another point is stability. For system stability, For LTI system stability, for an linear time invariant system stability ROC of its impulse response h of n, ROC of h of n means impulse response, includes, this must includes unit circle, then the LTI system is stable, right? So these are the points ROC in case of jet transform. Okay, very simple, you can remember easily. So thank you students, we'll meet again. Keep watching all videos regularly. Thank you.